Great. Hi everyone, welcome in. So you're back on the dusty numbers problem. So to recap, it's just trying to see how many redstone dust you can connect to a single power source. We've been experimenting with redstone blocks and with levers. This was originally a request from someone else for help making a lag machine. And okay, so I came up with like a new, I guess, perspective to look at this problem with off camera, and it helped. So I managed to break my own record for most redstone dust connected to a single redstone block. This was the old one here, 7,273. It's 167 less than the theoretical maximum, which is 7,440. That's just like the total volume of space that redstone dust can be linked to, divided by 2. So I'll go through the breakthrough, just how it works, how you look at the problem differently. And I have only applied this to a redstone block. And there's still even a few loose ends that need to be tied up for applying it to redstone blocks, but then after that we'll apply it to 2 levers. And hopefully with all that, yeah, we'll be able to solve the problem. So already I think we're easily guaranteed to get more than 7,000 dust attached to a lever. That was the initial goal. Now I think we might actually be in a position to, we'll probably, I'm going to guess like 7,000. I'm going to guess we'll break 7,500. But I think we might also even be able to prove like what the theoretical best is and maybe even build it. First though, should check that this is actually streaming. Excellent connection, says YouTube. Okay, great. Streamlabs told me today that their AWS servers were down. Okay, so the new way of looking at it started when I went back to the drawing board and actually tried to simplify the problem again. So as a reminder, what we did before was we said, okay, forget the lever. That's a little bit trickier. Let's just see if we can tackle a simple redstone block, just one block that's a power source. And to make that even easier on ourselves, we said, okay, let's imagine it just has a power level of 1 instead of 15. I don't have a mod that makes it power level 1, so we're just imagining that this magic redstone block only has power level 1. And if that's the case, there's only 6 sides, and so you can only attach 6 redstone dust to it. And then here's the best we could do for power level 2. You see we're missing 4 down at the bottom out of what's theoretically possible. So best would be 30, but connection difficulties make that a problem, so all we can get is 4. And then same with 3, 4, 5, you get the idea. Anyways, it turns out a lot of like the complexity, the thing you're optimizing with this setup is connecting your redstone dust to the bottom of the redstone block versus the side. The reason that actually ends up being significant is because, well, it changes how far you can reach. So when you connect your dust to the bottom, you can reach 1 block lower than you can connecting it to the side. And then oppositely, if you connect your redstone dust to the side, you can go 1 block further out to the left. But now you can't have the best of both worlds. So you can see here, I had to use a glass block because, well, if I had used a stone block, we would cut off this redstone line down here. So as a result, this block right here could, in theory, also be powered. But to power it, we would need stone blocks all the way up to the side of the redstone block, and we would cut off this ladder beneath it. Interestingly, this doesn't happen in Bedrock Edition. So in Bedrock Edition, there's no obstacle between the theoretical maximum and what you can build in practice, but there is in Java, which makes the problem more interesting. So, okay, because of that complexity, I thought to myself, okay, what if we just forget about the sides and just even focus on the downward wiring? Another reason this seemed like a good idea is because in all the best configurations I'd built up to that point, all the missing blocks, so the blocks that could, like, are within reach of the redstone block for power, but I couldn't connect to it because of, you know, the ladder cutting off other ladders constraint that I mentioned. All the missing blocks are in the bottom two rows. So with that in mind, I thought, okay, let's just focus on the bottom rows. So that's what I did here. So all we're doing now is just, we're forgetting about all the sides and the top of the redstone block and just focusing on powering as much as we can of the bottom two rows for, you know, an imaginary power level 1 redstone block, power level 2 redstone block, power level 3 redstone block. Chris, Platypus, hey, what's up, y'all? Welcome in. And this is where the interesting stuff started happening. So you can see the best I was able to do, you know, for power level 1, 2, 3, 4, 5. And I thought I was getting the hang of it, so I just went all the way for power level 15. And this is the configuration I came up with. I think this one has 98 chests. Yeah, 98 missing dust in the bottom two rows. Yeah. And dude, this got so cool right here. So I just focused on, I at this point I like super tunnel visioned on the bottom two rows and just even forgot about, you know, these kind of weird like root structures that lead down to them. And so here's a layout of the bottom two rows. Glass, red wool, green wool, blue wool, just for visualization. And you can see the red wool actually just makes a perfect grid. It looks like in this arrangement I had, so does the green. The green doesn't always, I think. Yeah, here's an arrangement where the green does not make a perfect grid. Anyways. And then blue starts to get a little less symmetrical. And, okay, I'm trying to think how to put this into words. You could almost just even simplify it further by, instead of focusing on the bottom two rows, just on the second to the last row. Because, you know, if you can connect every, if you can power every redstone dust in the second to last row, it just falls down to the bottom without a problem. I'm not sure that helped, but anyways, there's another special property that the bottom two rows have, which is that power will always come to them from above, just because, you know, there's not enough power level for the redstone dust to go lower and then back up. This bottom block here would be over 15 from the redstone source, from the source of redstone power, and would be off. So with all those simplifications, I just tried to find shapes that connected as many of these red wool redstone dust pieces while minimizing the number of chests involved. You can see there's kind of like this looks like a bunch of random shapes, but it's actually just the same shape rotated in a bunch of different ways. Thank you, Bit Defender. And what we're really getting here is 4 red wool blocks taken care of at the expense of 2 chests. Hey, what's up, Data? And I don't know, so you could almost now imagine like any shape of these red, green, blue wool you make has a cost to it. And this hits 4 red wool and adds 2 chests or 2 missing redstone dust to our total. So adds it takes the gap between the theoretical most dust you can connect and the actual you can and widens it by 2. So the cost is 1 chest for 2 red wool blocks. And just simplifying from 2 chests for 4 red wool blocks. And then power level 15 source blocks. So this bottom glass row is 15 blocks wide, and the red wool row above it is 14 blocks. So you can think of this as a 14 by 14 grid of red wool blocks. And the challenge now is to get as many of them as possible connected from above, minimizing the number of chests we add. The reason my first designs were so bad is because I basically just had like rings of chests in here, where it was like 14 by 14 wool, then a 13 by 13 chest ring, then a 12 by 12 wool, then a 11 by 11 chest ring. You see here already we're doing way better than that, because there's not perfect rings of chests. Like here, you could almost imagine if I was doing a perfect ring of chests, there'd be chests all around, but you can get around a few of those. So here's just the... Oh, no, this is... Okay, so this is the super cool new layout. Next, I just made different shapes with different chests and different coverages of red wool blocks. This is the one that's just been tiled there. You can see, if we have a 14 by 14 grid, this covers a 2 by 2 area. Again, I'm looking at it 2 by 2 diagonally, so 2 by 2 red wool blocks. Well, then there'd be 7 by 7 of these, so 49. And that's exactly where the 98 chests in this design comes from. We have 49 of these little connection modules, each one adding 2 chests to the total. So not all shapes have that, though. So this one is 1 chest per 2 red wool blocks. Here's another shape. This one hits 8 red wool blocks, I think. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, and adds 1, 2, 3, 4. So this is also 1 chest per 2 red wool. You can see what I tried doing was to overlap some of the chests involved, where this shape here is just like 3 of these glued together in the center. And, well, after trying a bunch of weird shapes, this is the only one I found that beat the 1 chest per 2 red wool. It has 3 chests, so 1, 2, 3, but it's 7 of the red blocks instead of just 6. Yeah, so check this out, dude. Like, it totally turns into a tiling problem. So it turns out that like the core of the reds, like, if you ask how many dust can I connect to a lever or redstone block, the answer comes down to tessellations. And what I did was first I squared off the 14 by 14 grid, so it's actually like, it looks like a square instead of a diamond. And then I made shapes for each of these different configurations. So our little 2 by 2 that adds 2 chests, I'm just representing with a little 2 by 2 red square. Where's another? Like, this weird shape that hits 8 blocks, adds 4 chests, is represented by this green shape. So 1, 2, 3, 4, 5, 6, 7, 8. The super shape, so the one that beats the 1 chest per 2 red blocks. So this is, this is 3 chests per 7? Something like that. Is represented by this orange bow tie shape. Where is it? Oh yeah, lastly you can glue 2 of these 2 by 2 modules together and you get a 2 by 3 shape. So that's represented here by the yellow 2 by 3 shape. And, well, if we were to visualize this first layout we made here, well, it'd just be a checkerboard. So it's just, a bunch of the 2 by 2s all next to each other. And then what you can do is you can get kind of weird and like glue a bunch of these shapes together. Yeah, so here's like 3 of the like wonky green shapes with a red shape in the center, and that would be visualized as this. It's kind of like a Christmas theme. And yeah, then the challenge now just becomes how many of these bow ties can you fit into a tessellation of a 14 by 14 grid using these shapes. And then, by the way, like, this also gives us a super nice lens for generalizing this problem. Because if we wanted to go crazy and have like a, power level 100, like redstone block, that's the source of our big, redstone dust power tower, then we could optimize that by just making a 99 by 99 grid and finding a tessellation of it using as many of these bow ties as possible. And I'm pretty sure you could prove pretty easily that the percentage of bow ties making up that tessellation tends towards 100% as the power level gets higher and higher. And, well, that gives us like actually a super precise like estimate of the best you can do for various power levels. Whew. So my first attempt, I just got, what is this, 4 of these in. 2 different arrangements that got 4 of these shapes. This is before I found the yellow shape, so no yellows in these 2. Then with the yellow, you can do a lot better. So I think this is an 8 bow tie layout. Yeah, that's 8. Even odd solution space. Yeah. One like way we might get closer to that is there's math happening here. Yeah, there is. It's a tessellations today program. Program trouble. And these bow ties we can't put within 1 block of the edge because, well, doing so would create a 1 wide gap no matter how you do it. And we don't have any shapes with like a 1 wide extension with a 1 wide arm hanging off of them. So you could like do this in a way where you just have like leftover gaps, and that would add 1 chest. So that's another thing we're gonna have to do today. Optimize with that condition. In other words, let's see, I need a new color now. What do we have here? We don't have a blue color. Let's do blue concrete. So we could, throw in another shape here, which adds 1 chest to our final total. So let's see, this adds 3, this adds 4, adds 2, adds 3, adds 1, something like that. And then, anyways, this is a 10 bow tie layout, and this is the best I was able to do. So we stick into Java and not Bedrock. Yeah, Crafty, the math like actually turns out to only be interesting in Java because Bedrock Redstone dust connections are a little less restrictive. Yeah. I think, yeah, I'll probably try to make a video on all this stuff. It turned out to be way more in-depth math than anticipated. Okay, so next what we can do is, well, we translated the downwards wiring of redstone dust in, from, well, just normal wiring to kind of a puzzle to totally just like a jigsaw puzzle. We can take our solution to the jigsaw puzzle and translate it back into a wiring setup. And this is just where it gets so dope, man. So here's the layout of chests for the 10 bow tie setup. Each one of these little like chest snails where it's like, has a little hump represents one of the bow ties. So bow tie, bow tie, bow tie, bow tie, bow tie, bow tie, and so on. Each one of these, I don't know, snails making a turn corresponds to a yellow 2x3 shape. Hey, what's up, Pineapple? Welcome in. And Yeah, these single chests represent, or are represented by the red 2x2 squares here. So downwards wiring to puzzle, from puzzle back to downwards wiring. And then from this chest layout, I just kind of hooked, put the rest of the layers in, as you would when wiring it. There are some constraints here, like for instance, when you're on the corners, the power has to come from up and to the right. There's only one direction you can power this little module right here, whereas, some module in the middle right here, like, yeah, we could power this from the left, but also power it from the right, and we could probably figure out a way to wire it up just fine. And then here's the rest of the wires put in. Now, you remember these big blobs, most of the shapes we found added one chest per each of the two red wool blocks that we covered. Red wool blocks forming a 14 by 14 grid in the downwards wiring. The bow tie shape saves us half a chest. I think, something like that. Yeah, I still don't have a good grasp on this math, like, conceptually. Like, so we probably got to spend some of the stream nailing down some metaphors to just help us think abstractly and visualize what's going on here. Because I don't think what we have here is enough yet. Anyways, we have 1, 2, 3, 4, 5, 6, 7. So this should add, what would it be? Yeah, 3. This should add 3.5 chests to the total. But it only adds 3. In other words, each bow tie saves us half a chest. Each bow tie adds half of a redstone dust block to the final total of how many we can connect to a single source. If we have 10 bow ties then, that adds 5 more dusts. And sure enough, I went through, ran a command, counted up all the chests in here, and it's 93 chests. This first solution over here was 98. So by using this weird geometry setup, we managed to shave 5 chests off the total for the downwards wiring. And then sure enough, here's, so I took that design from over there, filled it out with glass, added the next shell of blocks coming from the sides of the redstone block. That's going to be another place we have to optimize. Because, well, in Java Edition, this, like, wires coming from the sides of the central source and wires coming from beneath it kind of compete because they'll cut each other off. And so as a result, there's a big loop of chests all the way around this thing that we're not powering. And the reason for that is these could be reached if we had a wire coming straight down from the side of the redstone block. But doing that would cut off the wiring coming from directly to the bottom. Sam, what's your max right now? For a redstone block, the max is 7,286. These new techniques that we're working on, I haven't applied to a lever yet. So right now, the record for a lever is still under 7,000. And yeah, that's pretty much where things stand with the geometry problem. So many familiar names in chat. Yeah. By the way, like I've been streaming on Twitch for a few months before this. I just kind of stopped because a lot of people showed up. Yeah, a lot more people have been showing up on YouTube. So yeah, just thanks, guys. It's a lot easier to actually have people to talk to while working and explaining stuff. Okay, so at this point, gotta take what we learned over there and apply it to levers, which worked on over here a bit. Well, actually, okay, I'm gonna make a grocery list of stuff we still gotta do. You did one of the permaculture streams on Twitch, right? I think so. Yeah, no, I think a while back when I was working on the permaculture world, I would just open Twitch and if I was doing a really grind-heavy task that was kind of thoughtless. Now I'm doing the opposite, where like the most heavy-duty, analytical thinking I'm doing in my week, I'm doing on stream. Okay, so what do we gotta do here? We have to amend our puzzle perspective for levers. This is going to get a little bit weirder because with levers, the optimal... So we did some testing and figured out that the setup that lets us connect the most dust is having the lever on the side as opposed to the bottom or the top. Which means now we have 2 blocks underneath that can be a source of power from above. Which makes our whole downward pyramid thing a little bit wonkier and like less symmetrical. So that's one of the first tasks we're gonna have to do. Then what we got to do is balance side wiring with under wiring. So kind of like how I showed how the underside of wiring and the sides of wiring compete with each other. I think I built an example over here of trying to do this. Yeah, here it is. So what I did was I tried... Well, okay, you know, it's like first we were doing the downward wiring, kind of giving that priority, where in all 4 directions we were yeah, wiring from beneath the redstone block. And there is one problem that this adds, which is that you can't reach 3 blocks under the redstone block. So this area right here, there's no way to get power to it, which is a little bit of a downside to that approach. But, you know, if one of these arms you move out of the way, maybe you get rid of that, and then you wire this thing from the side, now you can get to that chest in there. So that's pretty much what I tried to do here. So instead I gave the side wiring priority, and as you can see, it knocked 3 chests out of that ring that forms around the side. Where was it? Yeah, right here. So this ring around the side could be reached from the sides of the redstone block, but aren't because we're giving the downwards wiring priority. Cauldron. Okay, y'all are having fun, and I'm not sure what you're talking about. That's cool, though. You're talking about your storage tech data? No. I'm just trying to keep an eye on the chest. I'm like, I'm pretty sure squirrels and snails aren't about the redstone dust connection. But it's so good that y'all are talking about them. It's just like, I'm not even sure how to verbalize like a lot of the thoughts or patterns here. Okay, giving this power coming from the side of the redstone block priority over the power coming from beneath the redstone block. We can knock 3 chests off of this outer ring here, but at the expense of adding 2 chests into the bottom here. Actually, hold on. Oh, this is getting weird. Yeah, okay, so now we're hitting 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay, so there's 8 red wool blocks here, and we're adding 2, 3, 4, 5, 6 chests. Yeah, okay. So normally 8 red wool blocks would require, you know, like just based on this configuration or all these shapes, 4 chests. You would have to create 4 chests, 4 missing redstone dust connections to wire up these 8 red wool blocks. And we created 2 extra chests at the advantage of shaving 3 off. So, okay. I didn't realize this till just now, but I guess this turned out to be an advantage. Yeah, okay. Yeah, so we added 2 chests to the loss created from the underside wiring, but shaved 3 chests off the wiring from the upper side. Oh, okay, cool. That's good. So what that means is, set block here. The optimal way to wire downwards would be something like this. So in one axis, you create, well, in one axis you give the underside wiring priority. And then on the orthogonal, the perpendicular axis, or, two-dimensional setup, the only other axis, you give the wiring from the sides of the redstone block priority. Yeah, just like that. Bring that down. And then kind of like here, where we still brought the underside wiring over, but just had to move it 1 block to the right and 1 block to the left. Same thing here. Yeah, so we do wiring like this. This is getting pretty weird looking. Something like that, and then the same thing on this side. That looks like an insect. Oh, what is that? 1, 2, 3. This is gonna be 8 legs. So an arachnid. Yeah, that looks super weird, dude. Okay, yeah, but this is the best way to wire downwards. And it looks so freaky. Looks pretty cool, though. Okay, so we have downward wiring like this, and then I'm gonna power this. We still need to add side wiring on the axis on which we gave underside wiring priority. To do that is we go glass, 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 just like that. Excuse me. Now each of these glass, or the redstone on each of these glass blocks can receive power from this downward ladder here. And then, yeah, we can downward wire like this. Huh, okay, it looks pretty good. Up. Cool. Yeah, just like that. Okay, so if we do this, we're gonna save, where was it? Yeah, 1 chest on each of the corners towards which we give side power priority. So that's 2. So on, yeah, that corner and that corner, we're gonna save 1 chest each. And now we can also power the underside here. Yes, that's the block right there. Because we can go down, something like that. Yep, and that saves another block there. Okay, so in total, this new downwards wiring setup should be able to save 3 chests from our current best, which is this one right here. Okay. Okay. Which means we should be able to get 7289 redstone dust there. And 7289, that might turn out to be what happened between them. Oh yeah, okay, I'll show that in a sec, platypus. 7289 might actually end up being the like absolute theoretical limit for redstone dust you can connect to a single redstone block. And we might be able to prove that actually. That'd be pretty dope. So platypus. Yeah, the problem, and this is a Java edition only problem, is that if you try to, put two downwards ladders right on top of each other, so go downwards, the ladder beneath, its power gets cut off by the ladder above it. This happens in Bedrock too, but one way to get around this would be like, oh, okay, well let's use glass blocks because those don't cut off power. The problem with glass blocks is they don't pass power downwards either, so it's just dead. So as a result, we have to, when we have ladders near each other, we either have to offset them like this, so one of the ladders is like one block to the side, or separate them by 3 blocks instead, so that we have 2 stone ladders, neither of which is being cut off, with a layer of glass in between them. So what's going on here is power is passing downwards along each of these stone lanterns. It's not passing downward along the glass here. What's actually going on is the redstone on top of each glass block is being powered upwards from the stone ladder beneath it. Although in Bedrock, we'll probably do this too, actually, while we're working today, is go on Bedrock and make the optimal wiring for redstone block and lever there, because we should probably do about 60, more than that, maybe probably over 100 more dusts than in Java edition here. I think, where is it? Let's turn on blocks, because breaking glass is actually pretty loud. Horizontally. Is there no disadvantage involved to putting 2 stone downwards wires so close together due to overlap between them? I mean horizontally because 2 wires are so close together at the lowest layer, wouldn't the dust receive power from 2 wires, thus being, oh, okay. So meaning, for example, something like here, ignoring this upper wire here, but just looking at these 2 downwards wires, it's like, why would you send 2 down? Couldn't you just get away with 1? The reason we're doing 2 is, well, if we disconnect one, this one won't be able to reach all the way to the right. And, oppositely, there's some dusts on the left here that the downwards ladder on the right can't reach. But yeah, totally, like, they're going to have a huge overlap, where there's a bunch of dust getting powered by both of them. But, even though most of the blocks they're powering are overlapped, there's a handful that aren't. And even in the optimal setups where you're minimizing that overlap, there's still a lot of it. But yeah, in general, you're totally right. And in fact, even if you look at, let's see, my older designs versus the new optimized ones, there are way less downwards ladders. So here's, yeah, this was my first attempt at wiring a redstone block's power, and you can see just, every 2 blocks we have a downwards ladder of some kind, almost creating a kind of fractal. But if we come over to my recent design, it's way less dense. There's still a lot, but it's like whereas before we had, was it like 7 downwards ladders coming off of this route? Here we have 2. Same thing here. 1, 2, 3, 4 of them. So yeah, in general it's true, but you're never gonna get rid of that overlap entirely, because if you do, you end up missing more blocks than you save. Okay. So this new downward wiring setup does have one weird effect. Should probably actually make sure this is the best way to do it. So these 2 chests are guaranteed, and oh, I guess so are these ones actually. Okay, so that's the best we can do. Yeah. Yeah, but what you noticed was totally correct though. I think that's the best we're gonna do for the corner here. What that means is, so let's make another 14 by 14 platform to practice on. This way I do this is just to clone an old one. There we go. Okay. And I think yeah, I built this world towards the negative X direction, which sucks because it just makes cloning everything a pain. So if we run over here. Okay, there we go. What this new setup does is it means that on 2 corners of our square, we're going to have more or less a 3 by 3 chunk missing. Not exactly 3 by. It's going to be more like 3 by 3, take 1. Yeah, something like that. Okay. Yep, that's what we got now. Huh, okay. Yeah, so now we're back to the same challenge, which is we need to cover this weird glass shape in our tiles, minimizing the amount of chests we add while we do so. It's a big bow tie. It is. Totally is. Bow ties are coming up a lot in this problem. If Redstone just had the same wiring constraints upwards, the skeletons of these things would also look like bow ties too. Like this thing with another one on top. Would they? It'd be weird if they had those wiring constraints upwards as well. Wire corner's gone now. So by doing, well, okay. So when we power everything as much as possible from the underside of the redstone block, so give the underside of the redstone block priority over the sides, then we get this big ring of chests down below. Put it down slightly. And this big ring of chests, how many is this in here? That's 15 by 4, so 60? Okay, so about maybe a third of the chests in the final design come from this ring on the bottom. Anyways, it turns out... Mute the music. Yeah. I'm gonna turn it down a little bit, because I like having the background noises a little bit, but if that's still annoying, just let me know. Uh-oh. Uh-oh, we got controversy in the chat. Okay. I'm gonna turn the music up a little bit, because I like it. Long term, I need to put together, like, a classical playlist that's, like, non-copyright. Anyways, okay, so, NBID? You do you, Chris. The music is great. Cool. we have this ring of chests on the bottom, and I realized that you can actually shave 3 chests off this side ring at the expense of adding only 2 more chests to the bottom row down here. And, well, what that means is, we can save 2 chests by giving the side wiring priority instead of the underside wiring. That gets this weird shape over here. We can, do this on one corner on the left. Do it, well, so one corner on the left, another corner on the right. We can't do it on all 4 corners, because if we gave, the side of the redstone block wiring priority on all 4 sides, well, now you can't wire anything at all to the underside. So two sides turns out to be optimal here. And this is nice also because it means we can get this redstone dust right here, which we couldn't get giving downward wiring priority in all 4 directions. What that means, though, is we get this weird shape in 2 of the corners of the very bottom of our design. Hey, what's up, Toby? Welcome in, as the streamers say. And, well, I've gone ahead and just removed those 2 chunks from the bottom. Or I guess oppositely, what we could do, is add in like the appropriately shaped tile here and just kind of remember that we can't like move this thing at all. It's not exactly the same tile because this green tile represents a downwards wiring shape that hits 8 of the second to last layer blocks, marked out by these red blocks, hits 8 of them, and adds 4 chests. These weird clumps on the bottom are a little different because they hit 8 of these red layer blocks as well, but add not 4 but 6 chests. We almost need like another shape. I should say also that we could just leave one of the red blocks unwired and that'll add 1 chest, so wait, first, what let's do is let's grab this, and this. Get some purple blocks, just because for whatever reason I've been using these to mark out the difference between the theoretical best we can do and what we've actually accomplished in practice. Hey, Hellranger, what's up? You've been very helpful in Cookie Clicker, by the way. Okay. First, I just want to lay these things out so it's easier to see what's going on. So probably do it smallest to largest real quick. Something like that. Sign above it there. Well, we put the sign like right there. Yeah, something like that. And then we got the red blocks. 3 between. Next we have the bow ties. And then lastly, I don't even know what this, it's kind of like a heart, green hearts. Okay, that's looking pretty good. And then that there. Now I'm gonna do is just mark how many more chests each of these shapes adds to our total. Did you try the Golden Cookie Farm Guide I sent you? Was it any good? I've never tried it, I saw other people recommending it for 7 golden horseshoes. No, I'm in the middle of the garden still, honestly. Probably try it. And right now I'm locked out of the game from doing my multi-saving technique. But yeah. That I'll test that and it'll be in the next episode. The next Cookie Clicker episode is gonna be like day 30 through 60, so it's still gonna be a while before it comes out. Hey, what are we doing here? This adds 1 chest to our total. Yeah, that's correct. Except if we have 4 of them together, this actually will add not 4 chests, but 5 chests to our total. This blue piece is like the worst one, so it's the only one that adds 1 chest per block covered, whereas, you know, this one only adds 2 chests, so it adds 1 chest for every 2 blocks covered. And then this one, this is 3, yeah, this adds 3, yeah. 3 chests and covers 6 blocks. And this one is kind of weird because it also adds, yeah, 3. So, not what I wanted. And lastly, this one I think just adds 4. Okay. Yep, this is what we want. And then this bow tie is the crux of the problem here. It's the heart of everything. Because this is the only shape that covers more than 2 blocks in the red layer for each chest added. So the problem now is, how do we use these shapes to cover this big board with the corners missing, minimizing the total of these numbers added per the corresponding shape? And, well, because the red, yellow, green all add the same to our score for how many blocks they cover, what we want to do is add as many as possible of these orange shapes and, yeah, as few as possible of this blue shape. I'm guessing we're actually going to add none of that. Hey, so time to start playing the puzzle. I think I'm gonna, like, the way I found, oh gosh, this shape. How did I find these shapes? I don't know how I found these shapes. Yeah, I think I started by placing this shape in the corner and then just building outwards. So I think actually, yeah, if you imagine, okay, that shape of bow ties and just kind of flip it upside down, it could still fit perfectly well right there. Or would it? Oh, maybe not. Yeah, no, it wouldn't, because this last bow tie would have to go, yeah, right there. And I don't think we really have any way to cover like a one wide zigzag like that. Okay. Yeah, this is gonna get weird. I'm not even sure it's possible to still fit 10 bow ties in here. Different shades of orange. Oh, okay, we can just go at it and see how it goes. The goal is to get 10. That was the best we did with a full 14 by 14 board. I wonder if you could... This work? Nah, because now we're missing that spot. What about... No, because now we're missing this spot. We could add a blue in. But now this total shape is just the same as the green one. Yeah, and that's 4 chests. Okay, so it's no better than the green shape. So I'm pretty sure the blues are just totally useless. Just gonna get rid of them. I hope that y'all are, like, furiously attempting the same task in your own Minecraft worlds right now. Okay. So next I did this. Oh, and then we get a choice to make. So the bow tie here could go like that. Or like this. Ooh, and if we do like that... Should use a different... That fits pretty nicely. It's pretty nicely indeed. Yes, we are. Are you serious? Okay. 14 by 14 or 15 by 15? It's 14 by 14 because it's representing the second to last layer of blocks being connected to our source power. So the very bottom is 15 by 15 because, you know, it's from power level 15. And then this bottom row is 14 by 14. What are you trying to do? I think you're trying to get the smallest number, and the shapes are a number like the bow ties. Yeah, that's correct. The bow tie at, like, it's kind of like golf where we're trying to keep our score low, and the bow tie turns out to be the lowest score per blocks covered. So we're just trying to cover this weird glass shape using as many bow ties as possible and these other shapes here. So we can't put the bow ties, you know, up against the wall like this because none of the other shapes fit in a one wide gap. And for whatever reason, it turns out that solving this problem also solves, like, maximizing how many redstone dust you can connect to a single source block, which is super weird, but hey, here we are. Are the other shapes equivalently weighted? Yes, they are all exactly 2 added, or 1 point added to your score per blocks covered, or in other words, for every 2 redstone dust they connect, they make 1 redstone dust unconnectable from our final, you know, connection setup here. As an example, take this little 2x2 red square. I don't think it's in here actually. Okay, let's take the bow tie. So bow tie has that weird shape. It is representing, yeah, this arrangement right here. So this downward ladder. And this downward ladder is covering 1, 2, 3, 4, 5, 6, plus 1 in the middle, 7, of these second to last layer red blocks at the expense of stopping us from connecting 3 redstone dust. And then every block in the lower layer is connected, so oddly the problem comes down to the second to last layer. I'm gonna try it too. Perfect. Okay, so here's what we got so far. What are we at here? 1, 2, 3, 4, 5, 6, 7, 8. Oh, we just gotta fit 2 more. Oh, can we get 12? Oh, man. That'd be great. No, that doesn't fit there. How are we gonna do this? Oh, I don't know if we can fit 12, actually. Oh, maybe. Man, we need a lot of different types of orange for this. I guess we're going with terracotta. We can definitely do that well or better. 12? 12 of these bow ties? Ooh. Okay, well here's 10 again. I don't know if we could wire this thing up, actually, or wire the rest of this thing up. Okay, we'll keep going. I'm gonna leave this as just a best attempt. Oh, that doesn't work either. 10 might turn out to actually be pretty hard. Okay, but whatever. Let's clone this and take another shot at it. What's the record? For bow tie tiles, the best I got previously on a slightly differently shaped board that had the corners was 10 of them. And the current record for most redstone desks attached to a single source redstone block is 7,286. Record for a lever is still under 7,000. I think we could easily do more than that. I just haven't attempted it in a while. Okay. What was I doing? I was cloning stuff. 2, 9, 10. I learned to count in other languages by watching Minecraft streams in foreign languages. Like in Skyblock when they're bridging off and have to like count out a certain amount. Like, uno, dos, cuatro, cinco. I'm like, language. A third of my German and Spanish I learned from Pokemon and Minecraft streams. Okay. Let's get rid of this again. Maybe try flipping this one. Yeah, something like that. A little bit of a weirder shape. Count in German. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. Welcome in to any Germans joining the stream today. Okay. That's looking pretty good. Yeah, that's correct. All right. This one I did before. What's the shape for 5? What do you mean the shape for 5? Is this a question about German or about these tiles? Man, if y'all are in a voice chat trying to solve this, just go like get some more coffee and y'all let me know when you're done. The green one. Forgot the shape. These tiles. This guy right here? Little heart shape. It's the shape for 5. Oh, you mean like a shape that adds 5 to your score? The green one adds 4 to your score. Yes. don't think this is going to give us any better. What are we at here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's not really helping. Let me try putting this first tile down a different way. So what are our options for our first tile here, actually? We could put a tile down like this. That's a perfectly legal start. Can't put one down like this. Oops. Can't put one down like this, because then, you know, we just have leftover block here, and now it's just the same as one of the green heart tiles. Have to start 2 away from the edge. So we could also start like this. And we could lastly start like this. These are all the different starting placements that we can build off from. I guess we could also do... Actually, yeah, that is a start. Yeah, that would work too. Okay, we tried that one. Only get... I'm not even sure I got... Is this 10? Yeah, but it's not even clear that this one could be wired up. It's kind of like a weird sword. Something from The Legend of Zelda. You know, I'll try wiring up from one of the corners this time, see how that goes. I wonder if there's any way to simplify this. Oh, that's looking not too bad. Maybe that is bad. Yeah, now we're missing those two. I'm not even sure 10 is doable now. Considering going back to the wiring grid to get an intuition for the tile shapes. That's a good idea. Yeah, actually, I'm not even sure that this is the only, like, the bow tie is the only, over-optimal shape. Actually, I'll probably go back to that with you right now. Grab this. Okay. How confident are you that these are the whole set? I don't know, maybe like 70%, 50%? Not that confident. Okay, so to wire up, you know, any of these glass blocks, power has to come from above. Yeah, some dust while I do this. Like this. But power also has to come to this red wool block from above. Because on the last 2 layers, power can only reach them from above, whereas from the third layer and up, it's possible to like wire them by going beneath them and coming back up to them, which did end up happening a lot for the current optimal redstone block design. So, you know, one of these 4 blocks here, or more, but at least one, has to deliver power to this red wool block. And if that's the case, we're losing 1 potential block of power. And then, same thing for the green block. It has, well, actually, I guess the green block also has to receive power from above as well. The reason for that being, if it received power from below, it would have at most a signal strength of 1, which, you know, would power it, but it wouldn't give it enough juice to reach downwards into this area. So green wool block has to be powered from above, and, you know, for that we have only 3 choices on Java Edition, because if we powered it from here, we would be cutting it off from reaching, I guess it's children. It's blocks beneath it that it's powering. So in other words, yeah, for powering the bottom, we are guaranteed to lose at least 2 chests like this. Or to create at least 2 chests, lose 2 redstone dust. So this shape is a guarantee. It could, you know, you could bend it like that, but you're not getting around the need of 2 missing, or of 2 chests, 2 missing dust, and a downwards ladder like this. So I think that means the only optimization left to be had here is overlapping the chests. So first of all, you know, whichever one of these, we have to choose one of these 3 blocks for powering the green one. You know, then we may as well add more red wool on the other 2 sides. Like that. I don't think there's anything to be gained from bringing wiring down, like, from 2 blue blocks to a green. Yeah, because all you're doing is reducing the total number of blocks it can reach. Okay. In that case, this is like the core shape, and then, you know, the question is just, yeah, where can we overlap this central chest? If we don't overlap it at all, we get the 2x2 tile, our red square over here, 2 chests. If we overlap all 3 of them, so as many as possible, we can't overlap 4 because doing so, well, again, power has to reach the blue block from above, which means one of the 3 sides is cut off from communicating its power downwards. So yeah, I guess that actually means there's, okay, so actually with that, with what I've just said, I think we actually have enough to deduce that this is the full enumeration of tiles. In other words, no overlap at all, get the 2x2 tile. If you overlap 3, which is the most possible, and is a unique shape, we get our green heart over here with 4 chests. And then lastly, if you overlap 2 of them, you can either do it on opposite sides, creating a straight line shape, or on adjacent sides, in which we create this kind of weird half pyramid shape. This weird half pyramid is the yellow tile, and straight across is the bow tie. There is obviously the option of just deliberately leaving one of these redstone dust or red wool blocks unpowered, just because it's not next to any green wool whatsoever. And that's what I had earlier, is like a little 1x1 tile. So yeah, I think that's pretty much what we're left with here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. But yeah, we'd have to add a 1 by 1, which just ends up ruining it. And you actually have to have an even number of bow ties here, because the area we're filling out has an even number of glass blocks. And the bow tie is the only one of these tiles with an odd number of blocks in it, 7. So if you had an odd number of bow ties, you'd have an odd number of total blocks covering, and one of the glass blocks would be left uncovered, which is the same as just covering it with a single 1 by 1 block. Hey, what's up, Reckon? And adding in a 1 by 1 block would be the same as just having one of our heart-shaped tiles here. So even number of bow ties, largest possible, is the challenge. I guess here's the shapes we have for 14 by 14, but we found an optimization that took out the corners, and now we're trying to figure that nonsense out. One, 2, 3, 4, 5, 6, 7, 8. So we could go for the 8 tile here. Let's grab red colors, yellow colors. Is that it? I thought I had 4 of these. Yeah, there it is. And we have this shape to work with. Maybe it'd be worth just screwing around trying to find regular layouts of the bow tie for a while. It's such a weird shape to work with. Okay, but we have this one. It kind of looks like a butterfly to me, or a goat head. There's its horns. There's the area chest ratio for the 2 corners again. The area chest ratio. So for the 2 corners we removed, the area chest ratio is worse. Normally it's 1 chest per 2 red blocks covered. Here, 3, 4. Yeah, we're adding 6 chests and covering 8 blocks. So 2 more chests than what would be optimal, but it's worth it because by adding 2 chests down here, we're shaving 3 off of this ring on the 2 opposite corners. That's an extra 2 chests saved, plus we can get under this block, so it's 3. So using the corners saves 3 chests. So even if we can get an 8 bow tie arrangement, we would have a net savings of 2 chests. What was I doing here? Okay, so I think we can tile that. And then we do concrete powder in here. Like that. It's like we go yeah, something like that. And where are we at now? 1, 2, 3, 4, 5. That's 6. Squeeze 2 more in, we get 8. Ah, that's an easy squeeze. That's I should use a different texture. What haven't I used yet? Concrete? Too many shades of orange, man. Too many shades of orange. There we go. Really? You should, Twitter or Discord or... You can describe it in the chat. At 6 dust and misses 3 by necessity. On Discord. Which window did I have my Discord open in? Oh yeah, that one. Okay. Sec. Now y'all just see only me. Oh, does it not show my... To join a creative multiplayer. I could join a creative multiplayer. How do I find my... I don't think it shows like my Discord number if I'm streaming currently. It probably shows it on my phone. Let's go back to the, the Minecraft screen. Dude, this is so weird that this is like the patterns we're coming up with for just wiring stuff to a redstone block. I wonder if streamer mode is like cross-device. Like if I'm streaming on, you know, my computer is gonna put me in streamer mode on the phone too. It does. Oh, but it does show my username. Okay. McBlaze. Hey, what's up, man? Hey, you're. This is actually related to your bedrock breaking video. Only what is going on? Gotta do this one. Or did you find me already? Oh, you did find me. Okay. Great. Okay. What is going on here? Let me try to... Is this... What is going on? Is this the same as this shape right here? Yeah, I think so. Or... Yeah, okay. I think... Let me clear inventory real quick. Go. Okay, so looks like y'all got glass, glass, glass. Like that. We got red wool here. Red wool there. We're connecting from here and here. Presumably red wool on the backside that I can't see. Adding another chest there. Okay, yeah, that's... Okay. It's 14 by 14, right? Yeah, that's correct. Like 2 or 3. This is isolated, so... this. Oh, but we got... Oh no, but red wool in the one spot I could see, I'm guessing. Okay. Either way, though, this is still... I think this is still less efficient, just because... Wave. Because we're hitting 1, 2, 3 red blocks and adding 3 chests. So we're not counting the total number of dust added, but the total number of dust added on the red blocks. So I think this is just a shaved down version of this shape right here. So it also has 3 chests, but hits 6 of the red blocks. Yeah. Is there any advantage to be gained in, like, just deliberately not using red blocks? I don't think so. I think these are the only tiles we have to work with here, unfortunately. When you have a breakthrough though with the different shapes you're making, see if you can convert it into like a coverage of the bottom 14 by 14 like this, and then count up how many chests are in it, and then that'll tell you for sure whether or not you've discovered a new better shape, because this is the best I could get for a perfect 14 by 14 grid, and it's 93 chests. Corresponds to this tiling right here. Okay. Yeah, so we're counting not how many dust these things hit, but how many of the red blocks. So red blocks are just how I mark the second to bottom layer we're wiring. I'm counting up how many of these red blocks are covered. So either, made inaccessible or made accessible to redstone dust. And the bow tie here hits 7, has 3 chests in the middle. At least that's... this is the perspective that gave me the best results so far, so it's what we're working with. Like, there's still a whole nother problem that we have to tackle, which is... Oh, okay. Yeah, if your Windows... I don't screen capture the game. I don't window capture the game, I just screen capture my left monitor. That way I can pull up, like, a picture or something if I need to. But it means you all get to see all the advertisements that pop up. What was I going to show? Okay. Let me just finish up this one. And just see if we can convert this into... Because I think we should still be able to shave... or to add 2 more redstone to this number here. 2 or 3. Maybe 3. How do you capture the audio? Do you have that on a different layer on OBS? I'll show you guys my OBS. So this is what I'm doing for OBS. I have just my microphones, Red Dragon, and then desktop audio. And some filters on it as well, because I'm near an open window and it's super noisy. Then y'all are right there on the right. Okay. I keep getting sidetracked. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Since this is 8, I don't think we can really fit any more into this. Yeah. But at the very least, this 8 bow tie layout will let us add 2 more redstone dust to our best redstone block configuration. Yeah. Really the best we can do, man. Oops. Yeah, I think so. Actually, oh. So in bid, there might be one place where there's a better shape available, and that is here. The corner shape. Didn't even think about that. It's... Hmm. There might be other shapes that are available right here. Like, you know, wiring, for instance, like down this way or something. But I think that would... Oh! Oh, hold on. Hold on a second, man. We could also... Yeah. Do a green block there. I mean, chest there. Oh, not... Yeah, green block there. It's red wool here. Like that. Okay, and now we're essentially putting one of our green heart shapes in the corner there. Okay, so let me go ahead. I don't even know. Use stained glass for this. Okay. So what's going on here is we have a little bit of flexibility in the corner wiring for our the two corners where we give the side of the redstone block connection priority. We can add 2 to the corners here. In other words, you can see we have 2 big chunks missing from the corners here, but we can optionally change the shape of these chunks by either adding or removing these blocks that I've marked in stained glass. We add... Yeah, and then we could, like, you know, add another green wool here or whatever. That would not be worth it, because we'd be adding 1 chest, but only 1 red block coverage. This little change, oops, on the left here is worth it, because we're adding, yeah, just 1 more chest, but 2 more red blocks, which means we're perfectly hitting the 1 chest per 2 redstone block quota, which is the quota that the bow tie slightly gets underneath of. Okay, cool. In that case, yo, we can just like, I don't know if it's gonna help or not, but we can change the shapes here. Oh, hold on a sec. Hold on a second, dude. What is this shape? I mean, I don't know if that actually helps or not now that I'm looking at it. Did I get that right? Variations of these? 2 by 2. Yeah, okay. Yeah, that's correct. Huh. Just gonna create a new spot to try this out. I tried a bit what happened while I was gone. I realized that there's slight flexibility in the shapes of the missing corner blocks here. Because there's actually a few different ways to do this weird downward side of redstone block wiring. So that flexibility might help, might not, but it's worth a shot, so I'm gonna fiddle with it. Okay, I've marked, so in other words, these blocks that I've marked in black stained glass, you can include them in this missing hole here, or you can get rid of them. And you don't have to get rid of both of them at once. You can keep one, leave the other, get rid of both, keep both. And I'm hoping that that added flexibility might just help us fit in a few more bow ties. These are orange blocks. Okay, I'm gonna give this a shot. Oops. That work? Okay, yeah, I think the problem we had was we fit this shape in before. You can see this bow tie is in the same spot as that one, but this corner here gave us trouble. Is this the 10 bow tie setup? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this is the 10 setup. Got, what is that, distance of 4 away? So 1, 2, 3, 4. Okay. Just to mark out the edges. Actually, I'll just clone this thing in. Okay, right there. Clone command, boom. Okay, there's our best layout from before. Question is, can we add just one more bow tie in? Preferably, can we add 3 more bow ties in? We can't rotate it. We can't rotate it because if we had like a corner right here or something, it would not match up with this thing. Oh, maybe we could rotate it actually. Oh, that's kind of weird. It gives us a weird shape there though. Yeah, I don't think that this is gonna work. How many we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. Green's in there. Yeah, I think 8's the best we're going to be able to do for now. But that's still savings overall. Oh, one option actually. Yeah, actually, would be just have only one of the corners missing. That's a whole nother level of flexibility. Having both corners missing saves 3. Having one corner missing saves 2. Okay. So let's just say we have this. still, this is 8, 3, 4, 5, 6, 7, 8. Yeah, 8 gives us savings of 4. Savings of 3 is a savings of 7. Or we could do savings of 5 and 2. Okay. Huh, I guess in other words, there's two different layouts that are 2 redstone dust better than our current. And as far as we can tell so far, I don't think there's any better than that. Yeah. New coffee cup. I just have another one sitting nearby. Hmm. I'm gonna eat a little bit while I stare and think about this. I won't stay too close to the mic. Snack break. It's Chinese food. I wonder if the microphone picks up me eating. Because I've already tested it and it doesn't pick me up beatboxing. Yeah, I'm about ready to call it quits with 8 of the bow ties Hell Ranger. I think trying to use both the corner trick and 10 bow ties won't work. Well, I mean, it might, I just couldn't get it to work. To pick up eating pears. Huh. A while back I watched a tutorial on, good audio filter settings. They're actually really good. Sometimes it doesn't pick up my voice because I talk quietly, but besides that, they're pretty spot on settings. So this is the 8 tile setup we got? Yeah, it looks like it. Okay, so let's just see if we can convert this into a redstone block connection, like we did with the earlier setups. Cool. Yeah, I have like 4 filters on or something. Like one is compressor, there's a noise gate, noise suppression, it's normal gain, I think. Okay, so now we gotta transform this. start with that. Yes, we'll just go ahead and throw the corners back in like that. Yellow. Red again. It seems like as long as you stay 2 or 3 blocks away from the edges and avoid some weird corner shapes, you can always wire this thing together. Yeah, that's looking pretty good. Put that right there. Let's see. Yeah, we'll just we could get rid of that corner if we want. Or actually no, let's take the extension this time. Yeah, I think that'll work. Okay, so now we're tiling everything on the outside of our bow ties. Great, and I think we're done. It's so weird how unsymmetrical this is. Okay, that's looking pretty good. So let's copy in now the kind of checkerboard diamond layout bottom. Fly way down here. Gotta line things up so that they look neat. That's probably good. Great. Alright, now we gotta start translating. So we're converting our tessellation into a bottom connection board. We do have to rotate it, I think 45 degrees, so we'll probably just go... Yeah, okay. Let's go... Chest. Need red stained glass, red wool. Stone. Okay, we should be able to start with that. So this corner right here, where we're, well, cutting corners, to connect, yeah, 3 dusts there along the outside. Gonna have a big loop of chests that can't be reached because of the interference between side wiring and underside wiring. Except again here. Nice. Okay, that's looking pretty good. That's cool. If there's a few other, like if this turns out to be the best you can do for the puzzle challenge, and if keeping like a 3-dimensional checkerboard shape is the best way to wire this thing up, which I'm like 99%, maybe 95% sure it is, Well, all I'm trying to say is there's actually a pretty good chance that we're making right now the absolute best, the absolute most redstone dust you can wire to a single redstone block in Java Edition. It's a shape that's hard to find, and it's probably never been built before in, you know, like the 8 years that it's been possible to make, which is crazy. We got chest here, all the way around these corners. And stopping right there. Always some of the coolest, like, Minecraft inventions is stuff that was actually possible, like 5-6 years ago. Just no one discovered back then. I'm thinking specifically of, like, the flying machines that have now been invented without slime blocks or observers. Or honey blocks, or... like, those things are just crazy. Okay. There's our 2 missing corners. Nice. Then we get wiring from above. Green and blue. Overtech is a beauty to watch. Yeah, it is. Okay, we got the right colors. Yep, some just like that. It's there and there. Here and here. Okay, cool. That's 1 corner done. Send this up 1 block further. Oh, I think I had green and blue switch in the earlier colorings. Yeah, I like that. Okay, there's that done. We got same thing over here. Adding 2 chests, removing 3. Adds 2. It's 3. Okay. If this all worked, we should be able to get 2 more redstone dust in our current best over there. If this all works. Okay. Looking about right. It's like some kind of battle arena. Okay, I think now we need to start copying in this tessellation. Yeah. Okay, cool. First we got... yeah, something like that. Then there are 2 chests like this. Wait, what's going on here? Is this correct? What are the chests for? Those are just how I mark to remind myself places. So we're trying to, you know, connect as much redstone dust as we can to a single redstone block. I put chests anywhere which is reachable from the redstone block, but which we're not putting redstone dust in. Because you can't reach everywhere at once. Yeah, it's starting to... Okay, so we have block, block, block. Yep. Just like that. Oh, okay, I gotta move these chests down. That. Ah, yeah. Ah, yeah. Yep, let me do another chest there. Do dust. Well, okay, cool. Yeah, that's looking correct now. Those two, I think. Yeah, just like that. Okay, that's looking pretty good. We have to wire these from this side. Probably wire these two together. Don't save anything, but just makes the wiring more compact. Easier to look at before we load all the glass in. It's looking pretty good. Green, 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 green. Blue. You know what? We could save... This design is, I think... Yeah, symmetrical, so we can save time by just building one half, and then I can flip it and put it on the other side as well. Okay, so we'll do that. Have... that, I think? Yeah, just like that. Looking good. Single chest there. And this is where the first bow tie goes in. Flip that. Okay. I think it goes in right here. Yeah. Yeah, that's the next one. Feels so weird to me how all this came out of just trying to wire redstone dust together. So unexpected. That's how a lot of the coolest math works. That's right. Yeah. Oh, is that right? There we go. Perfect. Sometimes it's hard to think when converting this like square grid over to the diagonal one. Okay, cool. Here we add this in. Think that. How to efficiently light spawn-proof a farm with spawnable blocks in a certain pattern. Yeah, that makes sense. Because you get those weird, because, you know, light doesn't obviously spread out circularly. In Minecraft, it spreads out in like a diamond shape. Which kind of just like, so the optimal lighting patterns turn out not to be perfect grids, but this slightly weirder shape. Was this beat 1. In the beat 1.7 world? Okay. I was like, I don't I don't think that's a question for me. Put these down. Yes, this looks like it's coming out pretty well. Nice, that's looking good. Evil Alexa. He was talking about Alexa, I think like the like, you know, no voice, like stereotypically stolen Minecraft build YouTuber. I think they were suggested twice in my home feed today, which is weird because I haven't seen any of those how should I say, lower quality creators for like 2 weeks. Kind of nice. Let's see, is this? Is that dead in the middle? 15, 1, 2, 3, 4, 5. No, it's a little bit to the side. So actually, will be a little bit faster to wire it from this edge. Evil Alexa. Just makes me think of Amazon's Alexa, but, well, evil. It's like not even like seriously evil. It's like, you know, Alexa, can you play the Beatles? And then it just starts flickering the lights and giggling maniacally. Evil Alexa is my nickname for Oreo. Not figure out what his profile. Oh, okay. Gotta do one more of these caterpillar shapes in the middle here. Yeah. This is what it looks like translating one of these puzzle shapes back into a downwards wiring configuration. Would flicker the lights on and off, and then yell disco party. All while poorly beatboxing its own music. I don't know who Oreo Lamp is, so I have no idea if this is accurate behavior of this individual. What am I doing? Putting another bow tie shape in. What I'm doing. Dank. Is that the left half done? No, we're still missing a couple spots. What do we got? Sideways bow tie and 2x2 is what it looks like. So sideways bow tie here. Only doing one half of it because I'm just going to mirror this. Oops. It's looking good. What was it, a 2x2 here? Okay, that's not too bad looking. Some dust on this thing. I should probably throw the green blocks down as well. Oh, oops. What am I doing? Yeah, I probably want to join this up with... Yeah. One of the easiest to wire this way. Here we go. That's looking pretty good. So we can throw down this last stone here. And this down here. Down here. There. I won't do that. Yeah, something like that. It's pretty compact. Oh no, we can't wire this from... Oh wait, we can just do that. Oh no, we can't do that either. Ooh. We might have just discovered another problem here. Huh. For this corner wiring to work, I'm gonna wire like that. But this thing, oops, it's a bow tie. What's going on here? Wait, is this a bow tie? What is going on here? Oh no, this is supposed to be a sideways bow tie. Yeah. This thing we can wire from this side, and that's not a problem, but then this one, it's a little problematic. So the wiring has to come in from there. Oh, wait. Whoa. We just do that? But if we do that, then... Yeah, like if we flipped it around like this... Maybe that's not a problem. Let's try setting it up that way. Oh, okay. Okay, and now, yeah, that works, that's fine. Okay, cool. This guy has to be wired off to the side. We can join it up with yeah. This, or maybe actually we'll yeah, try to join these two up here. Yeah, that's looking pretty good. Something like that. I think that should reach everything. We'll put a redstone block at the top and test it before we double the sides. Do we have the same problem here? Let's put that block there. That should be good. This is another 2x2 area. How do we want to wire this? I'm gonna come up like to right there. Maybe not actually. Okay, that's looking good. So what are we doing here? Probably actually just come up sideways like that. Okay, yeah, there's no problem here. Okay, cool. That should work. Oh, is that everything covered? Okay, that's looking good. Okay, cool. And then where do we... Redstone block goes here. Yep, connects to the side. Perfect. And power level 1 on all the edges, so it looks like we wired it everything up to the right length. We'll just start wiring all this down and make sure it all works. This is the Zen part of Redstone. I don't have any program or anything that like just slap down redstone dust on every open surface in an area. We're just doing it all by hand. Although we're going to use a little copy and paste. Cool, looks good. Okay, that area done. Oh, this thing's not even connected to anything. There we are. What's going to be a super bummer is if, like, you know, we build this thing all the way up, you know, we analyze it using a fill command or Lightmatica or something. And we see that, you know, it's like 1 or 2 redstone dust less than what our math and puzzle strategy said it should be. And we gotta find that 1 redstone dust that's not connected that we thought would be. What's this thing connected to? We can do up, up, up. Yeah, up to right here. I'd recommend world edit. I tried it the other day. Kind of found it annoying. I mean, I haven't learned it, so that's expected, but like most of the things that I thought I'd use it for, I already know how to do with Lightmatica. Or whatever. Okay. Yeah, that's about the same as Lightmatica. Maybe 1 or 2 extra clicks for Lightmatica. Actually, I think we can... Let's finish this, we'll double it up, you know, put it on the other side, and then right then we should be able to count how many chests are down here, and that should tell us just how much short we are of the theoretical limit. And we should be able to figure out if we really are gonna have a new record here or not. Or less clicks per action. Yeah. Are you modding the game in front of me? You a hardcore vanilla only player data? Or are you teasing us? I put off learning Lightmatica for weeks and learned, actually for this project, this one. Just doing a final scan. Sure every nook and cranny of Redstone's covered before I copy it. Destroy this, actually. Yeah, this looks pretty good, actually. Okay, cool. Get out the stick. Okay. Oh. There we go. Still new to Lightmatica. Still new to it. Okay. Okay, yeah, that's what we want. So we do M. What am I doing? Area editor. This is, what do I call this? Side priority half roots. You put question marks in these names? Oh, there we go. Probably optimal, but not like airtightly sure. How many clicks would world edit save? Lightmatter, you can analyze an area. 5 clicks and keyboard press. Probably less if you use hotkeys more effectively. True. Yeah, you just click analyze area. And... Yep. Oh gosh, dang it. Am I gonna have to name this thing again? Oh, no, cool. Side priority. Okay, whatever. Save schematic. Save schematic. And we change modes. We paste schematic in world. Load schematics. Which one did we just save? Side priority, half roots, optimal. Question mark, load schematic. Go to M. Loaded schematics. No, that's not what we want. What do we want? Schematic placements. Configure. We want to mirror this. Is that the right way? No, that's not how we want. So extend. What am I doing? Mirror. Okay, there we go. That's what we want. Place. Yep, there we go. Here's the other half. Quick look over. Yeah, should be good. Some of these on the other half we can get rid of, like this, you know. This wool block right here only needs power from one of these 2 lines, but yeah, that should be good. Cool. I think that's good. Go back through, and yes, we don't need that. That. Everything else I think we need. I did miss a redstone. Okay. Yeah, this is looking pretty good now. Anything else I need to do before we count up the chests? I don't think so. Yeah, because this bottom ring of chests is all that there's going to be. course, I just threw away the stick. Oh no. This fight's breaking out in my chat about world editing mods. Let's see what am I. This is what happens when you use a Lightmatica with shaders. Oh. Back placements, remove. Loaded schematics. Load that. We want area select. Here. Alt. Okay, that's done. Here. Okay, that area is in place. We got all of it. Let's see. Here we had 93 chests from our puzzle game thing, plus another 60 from the ring, plus 1 hidden right under the apex of this pyramid. So it's 93 plus 1, 94, plus 60, 154, which gave us this number. Okay, so now, area editor, analyze area, 152! Ooh, okay. Yeah. And that's exactly the number we expected. Because we shaved 3 chests off using the side power trick. But by doing so, messed up our puzzle game in a way that we were only able to save 4 chests instead of 5. So the net total we saved was 2. Ugh. That's pretty sick. Probably just gonna clone this over there. Okay, so now we go go to area editor, side priority half roots. We'll do full side priority full roots. This is both glued together. Quick double check, make sure it's wired correctly. Things at power 1 at least. Yeah. I did all not like y'all could totally be trolling around. I was like, oh, I saw a 0 right there. It's under the chest. Over there, no, not that chest. Maybe this is the advantage of getting your chat into mod discussion wars. No heckle you. Okay, okay. What are we doing? Area editor. Yeah, I'm saving this. Okay. Save schematic. Side priority full roots. Save schematic. Great. We're gonna paste it over here. So we need to go paste schematic in world. And schematic side priority full roots. Schematic. Escape. Great. Nice. That looks about right. Awesome, man. Hey, what's up, dude? Welcome in. Sweet. Sweet. Okay, so this looks like we have an even better solution to the redstone block. I'm gonna wire I won't wire the whole thing up, but I want to wire the parts that are tricky just to make sure there's no like unexpected problems that we're not thinking about. So do 2 layers of glass blocks, the apex of the pyramid, and we should be good to move on to the lever. And this, unless we can find a better solution to the bow tie puzzle over there for a 14 by 14 grid, this is the best you can do for redstone desks connected to a single redstone block. It's pretty crazy. There's no music playing. But if there is, I want to be ready. We could play jukebox stuff right now, actually. This be word? Nah, okay. I'll try that. What's the range of hearing a jukebox? Settings. Oh, really? It's a little softer. Sounds like it's not even getting... Oh no, that is quieter. There we go. After this, we're just gonna listen to the Deep Dark record over and over. Brain candy. The sound of apocalyptic marching. Hopeless feet drifting into the dark. Sorry. Gotta talk about something while we're just placing 100 redstone dust over and over. No problems powering this so far. wish there was a way to like hear note blocks from much further away. So it would actually be kind of fun is to like build our own music machine in a creative world. And we could put our own songs or whatever on it, our own drum beats. And then like, I wish there was some way to turn it on so it started playing whatever song you loaded into it. And then you could just fly off anywhere in your creative world and you would still hear it at a specific volume. As far as I know, I think facts right. Yeah, it just gets quieter as you walk away. In fact, I think Il Mango even did a video about pushing like note blocks or jukeboxes around using, I think, a carpet mod command. But because of the way the sound engine works, the sound doesn't move with you. I guess if you did a note block song, each note would be a new sound file, so it wouldn't matter. Yeah. I think, what is it? Peter Zhang? Actually, I've never even heard his name pronounced or their name pronounced. But another technical Minecrafter did make a flying song player using note blocks. Or like moved every measure or something. Okay, is that I think that's the third layer done. Okay. The thing is huge. It would be kind of funny, like as a meme, to make it follow you while you work in a creative world, though. The Crafting Federation? Might have been. Just looking it up. Do 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 do. They didn't call it a music box. What did they call it? A Walkman. Yeah, that's what they called it. So much stuff that's not Minecraft comes up. Maybe it wasn't Peter Zhang. They have some super cool stuff, by the way. If, in the off chance you've never heard of Peter Zhang. Oh yeah, okay, it was Peter Zhang. Yeah, this thing. I think it's crazy. That's a link to it. Yeah, I think I think I don't know actually what Zhang's did. I think Zhang's setup was something like the notes being played just traveled in like a squiggly loop back and forth, and just when it got to the end, the whole thing moved, and then its movement started that squiggly loop at the other end. Okay, so now we gotta do glass row here. Recently, Peter's been working on a lot of water tech, or like boat logic. It's another good example of something that's been possible in the game for like a decade, but no one ever did it. Sweet, there we go. That's all wired up. Same thing on the other side. Big step. I don't know a lot of the songs in here. Do custom maps so you can place a glass block above. Okay. Yeah, that's exactly the kind of thing I was wondering about. And that would be super helpful for this sort of thing. Because the copying and pasting with Lightmatica doesn't really work for a lot of the weird unsymmetrical shapes we have here. Because often there's not like a clear horizontal or vertical plane dividing the area you want to copy from the area you want to move it to. But doing a lot of stuff by hand is actually a way to improve your skills as well. I remember like years ago, like 7 years ago, when I was getting into Slimestone for the first time, I didn't use a lot of copy and paste or editing tools. It was pretty much just MC Edit at that point in time. To like build my big flying machine things. And if something broke, I usually tried to fix it by hand. I made backups and copies as well, but I found out by talking to people I did a lot more by hand than like most other people did, and the result was that I worked slower on like any one given project. But missed one there. By doing everything by hand, it gave me a much better sense for just how slime blocks, pistons, and whatnot all interacted. And same thing here, it's like, yeah, this is super slow, but you know, when you're staring at the pattern for a long time, you get a lot better sense of just how it moves and feels and thinks. So you know, like obviously I have the convenience of doing that because you know this isn't like a job or anything. I can go zen and take an hour to just place redstone if I want to. Kinesthetic learning. I guess this is the equivalent of kinesthetic learning in, like, as far as you can get to it in a video game scape. Unless you, like, throw your computer monitor. It could be a funny comedy skit. Having kids, like, bashing in their, you know, PlayStations, and because they were taught they needed to learn kinesthetically at school. Hell at it, you made any progress. Yeah, so we found a good way to like analyze the last two layers where all the missing redstone dust are using a like a kind of jigsaw puzzle problem. So right now I'm building up what I think might actually be the absolute best redstone wiring setup you can do for a single redstone block. So after this, I'm going to move on to levers, depending on how much like energy I have left. Long term would be interesting to like write a program that solves that jigsaw puzzle for like endlessly large squares. So part of me does want to know what like the best wiring setup would be for like a 100 power level redstone block. This is cool. It's like we actually have a pretty good sense of just what it, even without building it, what it would look like now. Ooh, that's interesting. Huh. That's all wired up. Excuse me. Yeah, we gotta wire up this edge somehow. Might get weird. Put this down. Would work. Yeah, okay. That doesn't create problems. Yeah, okay, cool. And same thing here and here. Cool. So that's edge. Yeah, this area might actually pose a problem. I think so. It's going to be wired from either side. Something like that should do just as well. Being powered. Yeah, looks good. Oh, that's not powered. Oh no, we are missing something. Oh yeah, we can't do that. We gotta wire it from this corner. Just like that. Do that thing there. Yeah, something like that. That should do. Okay, yeah, and then that's... And I'm just trying to get the tendrils, the roots coming down from the underside powering to not get in the way of the like roots coming down from the upper, from the side of the block powerings. That's clear of interference. So is that... Oh, so is this, maybe? Oh no. Oh wow, yeah, so that means... Yeah, all the... Oh, okay. So I'm just realizing now, popping up to you. Alright, see you, Data. You have a good meal. So before, on this one, we had to reach this outer ring, and I split the roots that reached it from the right and left, but now I'm just realizing that this new setup, the right is off limits, and we have to reach everything from the left. It's a little weird, but I don't think it should cause much of a problem. Yep, that reaches just fine. I think same for these two. It's a little more cramped, though. More math friends. Dramwerts. There's the smell of math in the air here. Is it Dramwerts or Dramverts? And yeah, we're, right now I'm just wiring up what might be the most possible redstone dust you can connect to a single redstone block. And earlier we used actually some tessellation, so some kind of like 2D jigsaw puzzles to optimize the bottom two rows. And with this down, the lever should be in reach. I'm thinking we can get over 7,500 desks connected to a lever, because with this setup we should be at about 7,300 desks connected to a single redstone block. Just encountered a problem, though, so I'm solving, that didn't exist for the old way we did it. I don't care, really. Wow. You mean about math? Or about math friends? Okay. Yeah, so this is the pattern I think we're gonna have to use here. About the name pronunciation. Oh. I've been doing this for 2 hours, man. Okay. I am kind of curious though which the right pronunciation is. so there's one side done. So the question is there anything that would stop us from doing this on the other side? No, I think it's... Yeah, I think that'd be good. So I'm not going to fill this thing out. Probably do it off camera and like show it if I make a video about it, but this... Yeah, I think this is the optimal layout of desks, connecting as much as possible to a single redstone block. Just get a label on top of it. Okay. That's Dramwert. Dramwert. I have the German skills of a kindergartner. Or maybe less. I have a few family members that speak Germany and like a cousin that visits every year or two. Most of my family doesn't really practice any part of our heritage though. I'm American, but my family came from Germany. 3. Can we say kindergartner? Yeah. Das ist. I don't know how to say true. Like wahr, nicht wahr. Nicht wahr. And this was 2 more, so this is 152 now. Take the jukebox out of the center now. Oop. There we go. Yeah, 7,288. 7,289 might be possible. But yeah, I think for now that's the best we're ever gonna do. It's crazy. Alright, you know what? I'm getting tired. I think I could go a few more minutes, but we're at a good stopping point now, so I'm gonna call it a stream for the day. Oh no. Alright, well, I've been at it for a few hours, Dram, so I think I'm gonna log off. But thanks for popping in. Alright, so 7,288 is the new record for most redstone desks connected to a single redstone block. Previous we got was at 15 less, so we've shaved off 15 more. And next time we'll take a shot at the lever. Alright, see y'all later. Thanks for joining.